sklearnutilsregisterparallelbackend. Description: the register parallel backend function in scikit-learn sklearn is used to configure how parallel processing is handled within the library. It allows you to specify which backend should be used for parallel execution of certain operations, such as fitting models or performing cross-validation. Inputs: backend, the name of the parallel backend to use. Common options include: threading utilizes multiple threads within a single process. Multiprocessing creates multiple processes to execute tasks concurrently. Dask, a distributed computing framework for scaling data analysis tasks. Loki, a multiprocessing-based backend that supports nested parallelism. Joblib, a library that provides parallel processing capabilities. None resets the backend to the default, which is typically threading on single-core machines and multiprocessing on multi-core machines. Outputs: none, the function does not return a value. It modifies the internal state of scikit-learn to use the specified backend for parallel computations. Steps: call sklearn utils register parallel backend and provide the desired backend as an argument. The function updates the parallel backend attribute within scikit-learn's configuration. Subsequent operations that use parallel processing will utilize the registered backend. Metrics: execution time, measure the time taken for parallel operations, e.g., model fitting with different backends to evaluate performance gains. Resource utilization, monitor CPU or memory usage to assess how effectively backends utilize available resources. Visualization plots: performance comparison plot, create a plot comparing execution times for various backends on a specific task. Resource utilization plot, visualize CPU or memory usage over time for different backends. Fine-tune parameters: number of workers for backends like multiprocessing or Dask. Adjust the number of processes or workers used to control the degree of parallelism. Backend-specific parameters: certain backends may offer additional parameters for fine-tuning their behavior. Uncertainty methods: the register parallel backend function itself doesn't directly address uncertainty. Challenges and fixes: challenge 1, choosing the right backend. Selecting an appropriate backend depends on the specific task, available resources, and potential limitations. Sample use case for tasks involving CPU-intensive computations and limited memory. Threading might be suitable for more resource-intensive or data parallel tasks. Multiprocessing or Dask may be preferable. Fixes: carefully consider the task's requirements, hardware resources, and potential limitations, e.g., GIL in Python to select the most suitable backend. Challenge 2, overhead of parallelism. Creating and managing parallel processes can incur some overhead, which might negate the benefits of parallelism for smaller tasks. Sample use case: a small dataset where the computation time for each task is negligible might not see significant speedup from parallelism due to the overhead involved. Fixes: experiment with the number of workers or processes to find the optimal balance between parallelism and overhead. Consider using parallel processing only for tasks with a sufficient computational workload. Challenge 3, memory management. Parallel processing can increase memory usage due to multiple processes or threads accessing data. Sample use case: processing large datasets with multiple parallel processes might lead to excessive memory consumption. Fixes: carefully manage memory usage by optimizing data structures, using memory-efficient algorithms, or employing techniques like memory mapping.